Science students to lesson number 1 in the climate unit, climate factors. So climate is different than weather. Weather changes all the time. Sometimes every hour it can change. But climate is much more predictable and stable, and if it's going to change, it tends to change more slowly. For example, sometimes we might have a very cold winter or a very warm winter here in Red Hook, but on average, you know what to expect every winter, and that's going to be different than what people in Florida expect because Florida has a different climate. Now, the two things we look at to determine a climate is the temperature and the precipitation, and we're going to show the data for these two things on a graph that's called a climograph. And some of you will be making a climograph in your labs and projects, but everyone will be needing to interpret climographs for the Regents and on tests. So let's take a look at what this climograph has on it. It's a complicated graph because there are two y-axes. The one on the left is precipitation, and this is a bad graph because there are no units for precipitation. So I'm going to assume that those are inches. Then if I go over here to the right side, I have another y-axis, that's temperature. And again, no units. And that probably is Fahrenheit. And along the x-axis on the bottom, we start in the January and we go through all 12 months of the year and ending up in December. Now the precipitation is always shown as a bar graph. So these are the precipitation amounts for each month. And if you want to know how much precipitation there was in April, you're going to have to go over here to the left and read it off the left y-axis. So this would be about 5 inches of rain in April. The temperature is always a line graph, and to read the temperature, I'm going to have to go over here to the right side y-axis. So what's the temperature in July? Average temperature, it's going to be about 80 degrees. So that's how I read a climograph, and we'll be getting more practice interpreting climographs later on. Now, the big task you have for this lesson is to learn these 6 climate factors by heart and to know how and why they affect the climate. For example, elevation will affect your climate. How does it affect your climate? I've put a T here. It affects the temperature. So elevation only affects temperature. Remember, we have 2 variables, temperature and precipitation. Latitude affects temperature. Topography, we're going to look at that. That's our windward, leeward. You heard a little bit about that in the weather unit. That one affects precipitation, whether it's wet or dry. Ocean currents affect temperature, so hot or cold. Prevailing wind belts, those are going to affect wet or dry precipitation. And the distance from a large body of water affects the temperature range, how much the temperature changes from season to season. So you're going to want to learn these 6 by heart and know which climate factor they affect. So notice that there's really only 2 that affect precipitation. Everything else affects temperature, and those 2 are topography, whether you're windward or leeward side of a mountain range, or your prevailing wind belt, which is, those are listed in your reference table. So if we look at elevation, this should make sense that as you go up, it gets colder, about an average of 3.5 degrees Fahrenheit for every 1,000 feet you go. So this here is Mount Everest. At the top of Mount Everest, it's going to be much colder than it is at the bottom, simply by going up in elevation. Latitude, well, you already know that near the equator, which is our low latitudes, you have a very high angle of insolation, so very direct sunlight, so that's going to make it hotter. And at our higher latitudes, we have a much lower angle of insolation, so the sunlight is spread out more over a given area, and so it's more diluted, weaker, and it's going to be colder. So let's look at a climograph for a location at a high latitude. So this is far north here, 60 degrees north in Canada. And what you can see here is that, let's look at the temperature curve, that if I look over on the temperature side here, here's 0. This is in Celsius now, so this is freezing point. There's a lot of the year where my temperature is below freezing. So this means I definitely have a winter in this climate. And we're going to define winter as a time when you have average temperatures below freezing. And in the summer, you'll notice it gets up to maybe 15 degrees Celsius, which is not that warm. So in the 60s, maybe. So a cool summer and a very cold winter. Now you notice the curve for the middle latitude has a very different shape. It's a little flatter and it's higher up. Notice here's our 0, and there's really not any significant time of the year where the average temperature is below 0. This is in Tennessee at a latitude of about 35 degrees north, so about 10 degrees or so south of where we are. So much warmer, and they would have therefore really a mild winter. That doesn't mean it can't get below 0, but the average temperature is not below 0. And here's Florida, Key West, Florida, 25 degrees north, a very low latitude, and you see the temperature curve is almost completely flat. That means they really only have one season, summer. So here you have our average temperatures above 20 degrees. That's would be in the 70s to 80s all year long, winter, summer, spring, fall. They really only have one season. So the climograph, if you compare it to other locations, can give you a really good idea of what latitude you might be at. Now all of these 3 had a bump in the middle, and that bump was in June, July. That's your high temperature, is in June and July. If I have a high temperature in June and July, then I must be in the northern hemisphere where June and July are summer. We'll see climographs for the southern hemisphere. There will be a dip in the temperature in June and July because that's their winter. So if latitude were our only climate factor, and there are 6, so there are more, but if it were the only one, then everything close to the equator would be hot, and everything at the poles would be cold. And in the middle, you'd be in the middle. But unfortunately, it's not that simple because the other 5 climate factors will interfere. Sometimes they'll cancel each other out. So you have to look at all the factors that affect your area to really understand the climate. But if latitude were the only climate factor, then I would expect that Quito, Ecuador would have the hottest climate because it's closest, it's actually right on the equator. And then as I go north, my climates would get colder and colder till I got up here in Canada. But it turns out actually that is not the case. Quito actually has quite a cool climate because there's another climate factor that's more important in that part of the world. Our next climate factor is topography, or whether you are on the windward or the leeward side of a mountain range. So for this factor, you need a mountain range and you need to know what wind belt you're in. So in this case, the wind is coming from the west. Now, sometimes the wind comes from the east, but in this drawing, it's from the west. So you always need to know which wind belt you're in to interpret this correctly, because as the wind comes from the west, this will be the windward side, and this will be the side where the air is forced to rise up over the mountain. And as you all know, rising air expands, cools, condenses at the dew point, and then can form rain. So this side of the mountain will get lots of rain because of rec. Now, as it goes down the other side, now it's sinking air, and you all know that is squeeze. Sinking air compresses, warms, and evaporates. So this side of the mountain range will be dry and warmer. So the climate factor here that we really want to focus on is windward is wet, leeward is dry. Ocean currents, on page 4 of your ESRT, you have a map of ocean currents, and basically if your currents come from the equator, it's going to make your climate warmer than you would expect, and if your current comes from the poles, it will make it colder than you expect. So that's pretty straightforward. And here's a map of ocean currents. It's a little different than the one you have in your reference table. It's in color. Yours is in black and white. But here the warm currents are in red. So you can see some of the nice warm currents that we have here, like the Gulf Stream, that actually brings warm water from the equator all the way up past the east coast of the United States, all the way across the Atlantic, up past Iceland and towards Scandinavia. And that makes these climates up here warmer than you would expect for their high latitude. So here's Reykjavik, Iceland, which is almost on the Arctic Circle. That's about 66 degrees north, and yet the winters aren't that much colder. In fact, on average, a little bit warmer than what we have in New York City at around 40 degrees. Latitude. The next climate factor is prevailing winds, and you have a reference table map for that on page 14. And this is rec and squee all over again. Where the air rises, it's going to expand, cool, condense, and be wet. Where the air sinks, it's going to compress, warm, and evaporate, and be dry. And it just so happens that happens. Rec happens at the equator, because it's so warm, and at 60 degrees. And it sinks at 30 and 90. And this causes some wet and dry zones that are very predictable on the globe. So let's start at the equator. The equator, you get a lot of direct sunlight there, so you're getting a lot of rising air. So this one is always going to be rising air. You're going to get wet conditions here, always at the equator. But if we go to 30 degrees north or south, you now have sinking air, and that's going to give us squee or dry conditions. So most of the world's deserts are either at 30 degrees north or 30 degrees south. That would be like the Sahara Desert. And most of the world's rainforests are at the equator, where it is very wet. We also have another rising air at 60, and we have another sinking air at 90. So the poles are essentially cold deserts. Our next climate factor is distance from a large body of water. And by large, I mean really large, like an ocean, not a lake. So if you are near a large body of water, and you know a lot about the specific heat of water and its ability to absorb heat and hang on to heat and to cool down slowly. So if you live near water, your winters are going to be mild, and your summers are going to be cool. So there'll be a very small temperature range there. If you live far from a large body of water, we call this an extreme climate because you're looking at land heating up fast in the summer, making it very hot, and land cooling down very quickly in the winter, making it cold. So this makes for a really large temperature range. So this would be in the middle of a continent, would tend to have extreme climate. Near the coasts tends to have a mild climate. And people tend to generally prefer mild climates, which is why most people, big population centers tend to be on the coasts. So if you put all of those different climate factors together, you can make a climate map. This is of North American continent. And you can see a whole bunch of different names that are given to the different combination of factors that result in different climate names. And we'll be, in the next lesson, looking at examples of different kinds of climate. So for today, go back and learn those 6 climate factors and how they affect climate. Do they affect the temperature or do they affect the precipitation, and why? See you next time.